I am going to start this video because I need to post this video today. Remember, after today, actual good videos. Like this one and the past one and even the past one was really fucking bad. Because I'm gonna start a project tomorrow, but it's late. It's almost 9 p.m. So this won't be any more than an hour, if that. So yeah, I will do my intro right now, and I'm gonna go play some games with some friends, and then I'll be back at some point to do one or two leak codes, and then that'll be it. But the thing I wanted to talk about was my project that I said I was going to talk about because I had it today, which was the last part of my semester. It went terrible. I mean, really, really bad. Um, uh, I had the demo code working. Um, at the school, like at a different part of the school than where we were actually doing like the demo. And it was working fine. Like all the servers were working. Actually, we never actually got the logic working, but it was functioning perfectly. Like it could go pick up the piece, move it to a different coordinate, and put down the piece. Whatever, fine. Um, on transport number one, the fucking arm broke off the stand, so I had to use a Phillips head screwdriver to like try to get screws into the wood. It took me like 10 minutes to get one screw into the wood freehand with a Phillips. So that was horrible. And then one of the wires came undone, and as I plugged it in, it burnt something. And so the motors just didn't work anymore. So I don't know how that'll get graded, but I mean that was terrible. So so yeah, that happened. But now I'm done. That's all my finals done, all the work done. So now I can actually focus on it is winter break, so we can actually work on some bigger stuff, and I can all my technical time will be dedicated to these videos for the next month and a half, which is amazing. So today's going to be the last day of really, half-assed videos. Um, and then um, and then yeah, and then we'll figure out what project in the morning what I want to work on. So yeah, um, that is the intro. So I'm going to pause here. Like I said, I'm just gonna do one and two leak codes today, and that's it. So I'll be back in what will be no time for you, but probably an hour or two for me. So yeah, I'm back. You ever watch that movie Sicario with Emily Blunt and Josh Brolin? I'm watching that right now. It's a good movie. It's a good movie. Anyways, oh, where were we? Here we were. Roadmap. Okay, we got two more easies. I suck at this binary tree stuff, by the way. Like I'm really bad at this. Like easies for everything else have been like actually easy. These, for some reason, I'm just struggling with. Given a binary tree, return true if it is height balanced and false otherwise. A height balanced binary tree is defined binary tree in which the left and right subtrees of every node differ in height by no more than one. A height balanced binary tree is defined as a binary tree in which the left and right subtrees of every node differ in height. So this is true because both of these are within one. A height balanced binary tree is defined as a binary tree in which the left and right subtrees of every node. So this node and then the subtree. So even though this only has one, it says no more than one. So this does have a difference of one, right? This one has a plus one, this one doesn't. Um, so we would need a way. So we just need to look at every single. We just have to look at every single node and determine. So like I start at root, right, left, right. If there is a left value and there is a right value, continue. If there's a left, and then go to the next node. If there's a left value and a right value, continue. If there's only a left or a right value, right, continue, but on the case that if there's now again another node attached to that one, return false, right? That's pretty much it. That's pretty much all it's saying. Is it saying, okay, recursive recursively check each node if it has both left and right. If at any point it has missing one. Also, it says have a tree to the left and right subtrees. So would if this went 1, 2, 3, and then it went 4, 5, and then it went 6, would that be valid? Let me ask that real quick. Yeah, EBT. If I were to have a tree with 1 as the root and 2 and 3 as the next level, then off of 3 is 4 and 5, then off of 4 is just a node 6. Would that be balanced or no? Node 2 has no children height of 0. Node 5 no children height of node 6. Again, node 4 it has one child. So I see. So would my idea here not work? So I was just gonna say good has left and right, doesn't have a left and right. Or okay, wait. In this example, this is good has left and right, and if it has one, yeah, so that wouldn't work because in this scenario, right? We're saying okay, yes, this has a left and right, and then I'm saying if and only, but this is unbalanced. Why again? Um, so why is that balanced, but this isn't? Is it the height of the left and right subtree from root and not just parent? node. Binary tree. Node 2 has no children, so it's balanced. Node 4 has no children, so it's balanced. Node 3 has a left subtree of 1. Ah, I see, I see, I see. No children is balanced. No children is balanced. 4 um, has no left child but has a right child, so it's value 1, which is balanced. And then we go to node 3. Has no right subtree, but it has the previous one and then this one, so it's a height of 2. And so it's not balanced at 2. I see, I see. Okay. So how do I want to flesh this out? So we're supposed to check if each node if point has missing on a node. Or not even this. It's right. It's like because my other scenario was wrong because we're checking like a height. I'm gonna use the bathroom real quick. Man, I also want to think about this. I'm back. Honestly, I didn't get much like thought wise because I'm just so the height, bro. A height of a balance tree is defined as a binary tree in which the left and right subtrees. So let's clarify what exactly is the left and right subtree, and I still don't get the height is. What am I actually checking? I'd assume it's just everything under like it's node 2 and then its tree, node 3 and its tree. A subtree, yeah. Left tree is 2 has no children. The right subtree of 1 is the entire tree starting at node 3. 3 and its children, yeah, okay. The height of a subtree, the height of number of edges. A leaf is a node with no children. If a node has no children, its height is 0. If a node has one child, its height is 1. If a node has two children, it's the height plus. If a node has two children, it's the height of 1 plus. Okay, so leaf nodes 2, 4, and 5 have no children, so there's 0. Yes. Node 3 has two children, so we calculate 1 plus the max between the height of this and this, which is equal to just 1. Because they both have, so this is recursion right here, right? Node 1 has two children, so the height, so we have 1 plus the max between 2 and 3. And so over here, because there's no children, this is 0. And because this has two children, this is 1. So this is 2. So we know that this is valid because we can do 1 minus 2. Right? Node 3 brings us 1. Node 2 gives us 0. And then from here, node 3 gives us 2, and node 2 gives us 1. Okay. I think I can solve this now. So basically, this is recursion. So I guess I can say node, if it has children. If not, the height is 0. If it does, the height is 1. At each node, we want to check 1 plus the max between left dot height and the right dot height. Right? So to kind of look at this, what I want to do is, for instance, in the example given, the valid one, where we have 1, 2, 3, 4, I would want to, well, this is weird because I have to start at the root, right? So I have to say, okay, well, because that's the thing, is I wouldn't want to do like, oh no, this would be the recursive call. I would say while while the node is none, right? Check the right subtree and then check the left subtree. 1 plus the max between both of these, right? And then this will go to a left or right if it has it, and a left if it has it, and so on, right? That's the recursion. My only thing is that once again, I forget how it worked where it, so it's the max between, oops, sorry. It's the max between the height of 4 and the height of 5, right? Okay, don't fully solve this, but when we do this recursion, what um what is actually saying the height is 1 or 2 for that instance? When we return from the deepest call, how do we keep track of the current subtree height? Because we did it, it's literally just this. Can I open this in a new tab? Okay, yeah. It's quite literally, if we go back to, I want to say this one. It's this where I say left depth, right? And I just say left depth, right depth plus 1. So if the max between, so if you see now, this literally should, I won't lie. I mean, again, like yesterday I said this was the same thing. But like, okay, so if the root's none, what are we returning here? A true or false. So we return true. If node is none, just like return, I guess. So we have the left depth in this, and it just goes through. So let me run this and just look. Whoa. So I'll have to do some checking on that. This will be returned true. And then I need a statement that's saying like if the left depth uh how would I even do this? I mean, I could literally just do if the left depth right one is not or can I not just do this? Is not equal to either 1 or -1, right? If it's not equal to any of these, then we want to return false. And then I want to do like a depth check on this, but I want to go look at this and see what it's saying. Why is it using so many emojis now? That's so funny. Um, 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 um. Between none type and none type. But if oh, I should because I'm saying okay, if what I'm passing through is none, blah blah blah. So I could just do like if left depth or right depth is none, just return a runtime error. Oh, what did I do? None. On what case? I need to check this DM real quick. I'm back. I don't know why trees are just stumping me, bro. Every single one is the same fucking thing, but it's like, uh, okay. Again, don't solve this for me, but fix or hint at my logic errors here. Oh, so if the node is none, I actually just so like if we go through, like if I pass through the node, right, which is the left or right, which actually no, no, this is fine. Wait, but if this passes through the left and right of the node, because there is the scenario in which, so this is the left and right, and it has a null null, and then the four, right? Because two has nothing on it, and then it just has the four on three. Uh, just fix my errors here, actually. Return zero instead of an empty node. Find depth. This. Check for imbalance and propagate it up the recursion. So if the left depth or right depth -1 or the absolute value is greater, then return as it's unbalanced. What? Why? I mean, I get this, but why this? Return maximum depth of two. So then that's the recursion. Not the recursive call, but really. So this works. That's what you're telling me. Okay. Let's find out why you work. I don't really need you right now. So I understand this. If it's none, return true. It's balanced. If node is none, return zero instead of none for an empty node. So if the node is just empty that we pass through, okay, yeah, just return none. Cursively calculate, yes, I understand that. I don't understand. So if the left, if this returns with -1, why would this ever return -1 though? Why do we check -1 on a return? When would this ever happen? At any point where the is determined to be unbalanced, we should. Okay, I get returning -1 to say that it's unbalanced, right? Because we don't want to recursively call this again if it is equal to -1. Sure. Wait, leaf nodes like 6 and 4 are balanced. 5 has a height of 1 from 6, and the right has a height of 0. The difference is 1. We're still balanced. But when we get to node 3, we see the height from the left child, which is 0, and height from the right child, which is 2. Oh, I guess so. Yeah, add 0 minus 2, we're going to get a. Yeah. Oh wow. Yeah, this matches. Wow. Okay, yeah, I get that. Okay. Yeah, that makes sense. Oh wait, this is the wrong. I exited out of the wrong one. This is the one I want to run. Okay. So what is happening in to where I'm not getting this? I think I still have to like sit down and just like again, what I want to make is a visualizer, an ASCII visualizer. That's the project I'm starting tomorrow. I'm doing it now because it will help me a lot because it's just like something like this. It's like return so 0 0 plus 1. So now it returns a 1 on what? It means oh my god. I get it now. Left depth is equal to find depth at node dot left, right? So what it's doing, it's saying return max of left depth plus 1, right? And so then it goes again and it keeps going until it's at the bottom. And then it's like, okay, max of this plus 1 on this left depth recursion. So this is now plus 1. 1 is getting returned. So now left depth is 1. So now when you go here, it's like left depth is 1, and maybe when this returns, it'll be 1, and maybe it'll be 0, maybe, and then maybe this will be 2. I see. I see. Okay, that makes sense. That makes sense. Yeah. That's why yeah, tomorrow we're doing Advent of Code, and then we're starting that project. And so I need to upload this video and get something to eat, but um, the project idea, which I'll elaborate and flesh out tomorrow, is something like ChatGPT, right? And I kind of love this format of a text on the left and then like a kind of playground or no sandbox is more of the correct term. And I want it to be you prompt it with like um, show me how recursion works, right? For instance, or in this instance, show me how this is happening with with a tree of this, and it'll generate a sequence of ASCII characters that tell a story, and they just visualize what is actually happening here. Um, I don't know how it's going to be done. I don't know if I'm going to have to be fine tuning models, if I'm going to have to be, if just using 4.0 and setting strict parameters will work. We'll find that out tomorrow. But that's the idea here. For um, that's the idea for tomorrow is getting that visualizer done. So getting it done. No, not getting it done. That'll probably take weeks and weeks and weeks. But starting it and getting the idea done tomorrow and getting, what we could possibly use. Is it's just going to be 4.0? Do we have to fine tune something? I don't know. Maybe I'll figure that out. So I'll see you bright and early tomorrow for finally a video that is not dog shit and it's me struggling on easy tree problems. Um, and hopefully once the visualizer is done, I won't be running to ChatGPT. I'll just be running to that and saying, "Hey, on this input, what's actually like happening in a proper solution or something like that." I don't know. We'll flesh it out. First, it's just gonna be with code, and then it'd be really nice to do like mathematics at some point with it. But that's even if I get the code one working. So, anyways, I'll go into it more in the morning. So, because I don't even know what it's gonna entail. So yeah. Have a good rest of your evening or day, whenever you watch this. If you're watching this, if anyone's watching this, yeah. Bye.